Second. Okay, so this is 6.4, number 3D. So we are solving rational equations. So we have an equation here with the equal sign. And we also have rational expressions. So a ratio of two polynomials. So that's what rational equations are. And in order to solve, what we want to do is we want to eliminate the denominators. So we want to multiply every term by the lowest common multiple of denominators. That is, every factor that's in the denominators once, okay? So a good idea is to factor the denominators. That's always the first step that I suggest. You do not have to factor the top, as I mentioned. Don't factor the top, but factor the denominators. This one is already just a single factor. It's prime. You can't take anything out of it. This one, x, really has just a denominator of 1, so that's not an issue. This denominator, though, on the bottom here, can be factored as x plus 1 times x minus 1. Remember, that's a difference of squares. You see that? So now is a good time, because I think you have to note restrictions or state non-permissible values. So now, before you get rid of any denominators, a good time to look at the denominators and to identify those. So x cannot equal, because it's going to make the denominator 0 if x is what over here? -1, good. And what about over here? +1. Yeah, so you could do this, plus or minus 1. That's a little abbreviation you can do. I'm okay with that. Okay? So there's nothing here. That will never be 0 because it'll always be 1. And we've already got the +1 here and the -1 and the -1. So it's all taken care of. Okay, so now what we need to multiply everything by is we need to get rid of the x plus 1. I see that here and here. I need to get rid of an x minus 1, so you multiply by these two. And don't worry about the 1. The 1 is, it's not even there, right? So it's this factor, and this factor that you got to get rid of. So we'll multiply everything by that. Now, here's the tricky part. Second tricky part, first of all, is identifying what you want to multiply by. The second tricky part is making sure that you take good account for what's left over on top. So when I multiply this group right here by this first term, notice the x plus 1s would cancel off, okay? And I'm left with this x squared plus x plus 2 times x minus 1. So we're going to have to do some multiplying out here, but this is what's left over here, okay? We'll get to that in a second. Now, of course, we haven't really eliminated this for good, just for that one term. When I multiply this by a minus x, obviously I have x and x plus 1 and x minus 1. Nothing gets divided out for the second term. Yeah, hi.
Would it be okay to put the x plus 1 and x minus 1 into x squared minus 1?
Okay, if you multiplied everything by x squared minus 1, is what you're saying?
For the x.
Yeah. We're gonna multiply all this out anyways. Yeah, you could write this as x squared minus 1. That's fine. Yeah, if that's your question, totally. It doesn't matter. I just didn't want to do that to confuse anybody. Okay, so now over here, look at both of these are going to get canceled off. So I just have nothing really left, and I just have the x squared minus 5. Okay. All right. So at this point, now we've gotten rid of the denominators. But it still looks a little complicated, right? So what we're going to do is we're going to multiply this all out to get individual terms. We're going to multiply this all out to get individual terms, and then we're going to gather all the like terms on one side, let it equal 0, and see how we can solve for x. So if you have a trinomial times a binomial, you just have to make sure that every term here is multiplied by every term in the second one, and then you just keep repeating that. So x squared times x is x cubed. X squared times -1 is minus x squared. Okay? Now you move to the next term. So x times x, and then x times -1. So x times x is plus x squared, and then x times -1 is minus x. Then the last term here, plus 2, let's multiply by x, so that's plus 2x. And 2 times -1 is minus 2. Okay, ignore that bell. Okay. So does everyone see how this multiplication gives us this? We have some like terms that we could gather here, yes, and maybe we'll do that next step. But when you multiply all this out, distribute, that's what you get. Good? All right, let's do it again. Minus. Now remember, we're subtracting what's going to be a bunch of terms, so you got to be careful with the minus that you distribute the minus over everything. So I use a second set of brackets like this, the square ones usually. So let's do that. I'm going to leave those square brackets because I got to remember to distribute this minus sign when I'm all done. So this is going to be x times x and x times 1, so it's going to be x squared plus x. And now I take that and I multiply it by this x minus 1, right? So I'm just going to do one step at a time. I'll come back and do this in a minute. And over here, I don't change anything. All right. This is a long question. It is. This is not easy. This is big kid stuff. So just stick with it. Stick with it. You can do it. So I'm gonna gather some like terms what I can over here with all this mess, and then I'm gonna multiply this out and so on. So let's take it one step at a time. So look at this minus x squared and plus x squared. They cancel each other out. You see how that's gone? I have an x cubed that stays. I have a, look at this, minus x plus 2x. What does that simplify to?
1.
Plus 1x, or just plus x, right. And then minus 2. Okay, so what's going to be inside these brackets when I multiply this out? Well, x squared times x is x cubed. X squared times minus 1 is minus x squared. And then I have x times x is plus x squared. And x times negative 1 is minus x. Okay, so I'm just kind of simplifying little things at a time. I'm going to show lots of rows of work here. And to be honest with you, like I say, guys, don't rush this. Don't do too much in your head. Don't try and do too many steps at once. You know, leave the stuff that you're, look at, I haven't touched this, I haven't touched it, I haven't touched it again, but I'm still rewriting it. If you don't rewrite this, you might forget about it, honestly. It's happened. It's happened, I've seen it. So just rewrite what you're not touching so that everything stays accounted for, okay? Trust me, it'll be easier on your brain. All right, so you don't have to do this step, but this might help some of you because this minus messes everything up inside here, right? It changes all of the signs. So I'm gonna rewrite. It's not gonna take me much effort. This minus x cubed is gonna be a minus x cubed. When you subtract a negative x squared, that's like adding x squared, you see that? When you subtract a positive, you minus. When you subtract a negative, you add. So to get rid of those brackets, you really have to distribute this negative sign. So this should be, everything should be, the signs all should be correct right now. And now with the brackets all gone, I've got no more negatives or numbers to distribute. Now I can start to, again, continue to gather like terms. So look at this, x cubed and minus x cubed. Those are gone. Just stroke them out like I do right there, and then they're gone. Then they cancel each other out. What else? Ooh, x squared minus x squared. You see that on the same side? That's great. Those are gone. I have plus x. That's going to be 2 x's. And then I've got this minus 2 that has nobody to pair with, so I'm going to leave the minus 2. And I can't forget about the x squared minus 5. You with me so far? We okay? All right, it's a long question. You can do it though. Don't hold, listen, don't hold your breath while you do math. Now, what I mean is, like, don't try and rush through all of this stuff to just get to the answer and then be like, I'm done. Okay, I'll try the next one now. No, just breathe, relax, lean into it, okay? Yes, you're going to be showing a lot of work, but if you can keep track of it in your mind, it's not going to be too difficult. It's just going to take some time, that's all. So breathe while you do math. It's okay. Take one step at a time. So now I need to get all of these terms over to one side so I can let it equal 0, because it looks like I'm going to have a squared and an x and a constant. So it's going to be a quadratic. So I like the x squared term to be positive, so I'm going to bring everything over to the right side. So this 2x is going to come over here as a minus 2x, you see that? This negative 2 is going to come over here as a plus 2, you see that? So I've got 0 equals x squared minus 2x minus 3, because negative 5 plus 2. Ignore that bell. All right, so now this is familiar territory, right? You have a trinomial. You say to yourself, I'm going to try and factor it and use zero product principle to solve for x. Or you can use the quadratic formula, still on the board over there, right? So can you factor this by sight? Do we have two binomials that looks like what multiplies to -3 and adds to -2? Do we have something?
-3 and positive.
-3 and +1. Very good. -3 plus 1. Those multiply to -3 and add to -2. Very good. So it looks like x should equal, using the zero product principle, what makes this 0? +3. And what makes this 0? -1.
Yeah,
And then what?
it can equal negative.
Ooh, you guys are good. You remember what our restrictions are. Very, very good. I'm impressed. So you would say to yourself, hey, x equals -1 is a restriction in this question, so I cannot include this in my final answer. So therefore, x equals 3 is your final answer, with x not being able to be equal to +or -1. And there you have it. That is the conclusion of this question. Did anyone get that answer when you just did this the last? Okay, one hand, one solo hand. Okay, congratulations. Another one? Oh, there's just a okay, a little hand. One big hand and one little hand. Okay, two of you. All right, now listen. This is 6.4. That's one of the tougher questions you get. Okay. In 6.4, we haven't done really many word problems yet. So after your quiz on this stuff, we're going to do some word problem questions. Okay. So I'm going to give you a little quiz on this now. You ready for it? Yay! Say yay! Yay! Listen.
That was easy.
Look at that was easy. The easy button said so. All right. Boom.